All right, let's dive in. Today, we're tackling a challenge that I'm sure every single AI developer has run into. How do you build a system that doesn't just work on launch day, but actually gets better and evolves in the wild? We're talking about how to future-proof your AI.
And this quote, man, it just hits the nail on the head, right? You spend months training, you fine-tune this beautiful model, you launch it, and everything looks amazing. But then, bit by bit, the real world starts to shift, and your model's performance just silently starts to degrade. It's a super common and incredibly frustrating problem.
So, what's the move here? Look, the answer isn't just to go build another model, a better one. The real, lasting solution is to think bigger. It's about designing a resilient system, an architecture that is built from the ground up to learn and adapt.
Okay, so before we can fix it, we've got to diagnose the problem. Let's talk about what this model decay actually looks like in the real world, because it's a silent killer for AI projects.
I bet some of you are nodding your heads right now. Your accuracy metrics start to dip for no obvious reason. The model starts refusing to answer totally valid questions. And it definitely can't handle the new features your product team just shipped, because that stuff wasn't in the original training data. So what happens? Usually it's a panic-fueled, super expensive, full retraining from scratch. That is not a sustainable way to live. And here's the kicker. All of these problems, they pretty much boil down to one single massive design flaw. Your model is on a one-way street. Data goes from training into production, and that's it. There's no automated way for it to learn from what's actually happening with real users. Without that feedback loop, decay is pretty much inevitable. So if the problem is a one-way street, the solution is pretty obvious, right? We have to build a two-way street. We need to stop thinking like we're just training a model and start thinking like we're building a system, an automated, continuous loop that gets smarter over time. And this is the map. This is our blueprint for that system. This continuous learning loop takes you all the way from a user getting a response, to capturing what happened, to deploying a smarter, safer version of the model. Every single step here is designed for automation, turning what used to be a fire drill into a smooth, predictable process. Let's walk through it.
Okay, step one. It all starts with the data. But here's the thing, it's not about collecting more data, it's about collecting the right data straight from the source, production.
You don't need to go crazy here and log every single thing. You just need a super simple but incredibly powerful piece of information for every single inference. What was the prompt? What did the model say? Which version was it? And most importantly, was the outcome good or bad? This little JSON object is the seed for everything that follows. If you're not logging this, you're basically flying blind.
Now, with those logs, we can get surgical. The brute force method, the way we used to do it, was just to take all your production logs and dump them back into the training data set. It's slow, it's expensive, and honestly, it's pretty inefficient. The smart money is on focusing only on the failures. That's where the richest learning signal is.
And we're talking about specific, high-signal failures. When did the model hallucinate? When did it get a classification wrong? When did it totally mess up the JSON format it was supposed to output? Or when was it way too cautious or not cautious enough? This small, curated data set, this is like concentrated learning. It's pure gold.
So we've got our gold standard dataset of failures. Now what? Are we going to kick off a massive week-long retraining job on the whole model? No way. We're going to make a small, precise update using a technology that is perfect for this. And that tech is PEFT, or Parameter Efficient Fine-Tuning. And honestly, this idea is a total game changer for production AI. Instead of messing with your giant billion-parameter base model, you just train a tiny little set of new parameters, we call it an adapter, that teaches the model how to fix its mistakes, all without touching the original model's weight. So let's visualize this. You start with your big, powerful base model. And the most important word here is frozen. We don't touch it. We leave it as is. This is our stable foundation.
Now, using our little data set of failures, we train a lightweight LoRa adapter. You can think of this adapter as a tiny, clever little patch that you apply on top of the base model. It nudges the model's behavior in the right direction without requiring a full brain transplant. It's like adding a new filter to your camera lens.
And the beautiful thing is, you just keep doing this. A new problem comes up in production, you curate the failures, you train a new adapter, V3, V4, whatever, and you just stack it right on top. This gives you an amazing traceable history of how your model has learned and evolved over time. This right here, this should be your mantra. Print it out, stick it on your monitor, never overwrite, always append. Why? Because it prevents catastrophic forgetting.
where fixing one thing accidentally breaks 10 other things. And it makes rollbacks a piece of cake. If V3 is acting weird, you just turn it off and you're instantly back to V2. It's safe, it's clean, and it's efficient.
Okay, so we've trained our shiny new adapter. We're done, right? Not even close. Now comes maybe the scariest part for any engineer, actually getting this new code into production without, breaking everything for your users.
So here's how you do it without giving yourself a heart attack. You follow a simple, methodical pattern. First, you deploy the new adapter, but you don't send it any real traffic yet. Then you start a canary release. Send just a tiny slice of traffic, maybe 5%, to the new version. While that's happening, you can run it in shadow mode, basically having it process live traffic in the background and comparing its answers to the old version. And this is absolutely crucial. The decision to promote the new adapter and send 100% of traffic to it is not based on a gut feeling. It's not made by a product manager in a meeting. The data makes the decision. When your automated metrics prove that the new version is objectively better, fewer errors, better accuracy, then the system promotes. So when you step back and look at this whole process, you realize it's not just a collection of cool techniques. It's a totally different way of thinking about building AI. It's a mindset shift from building static artifacts to engineering living, breathing systems.
So if you're going to remember anything, remember this. First, stop thinking of this as a job someone has to do. Build an automated pipeline. Second, use PFFT. It is your best friend for safe, fast updates. Third, focus your data collection on failures. That's where the value is. Always protect production with canary releases. And finally, make sure everything is traceable. That is the absolute backbone of a robust, future-proof AI system.
So I'll leave you with this question to take back to your team. Take a hard look at the AI you're building right now. Is it a static thing, basically designed to be thrown away and replaced in 6 months? Or is it built with this continuous learning loop at its core, ready to adapt and get smarter for years to come? The answer to that question really matters. Build to learn.